Okay, so now we are looking at a hyperbolic function. And in this case, they say we have the graphs. We have two graphs in this case. The first one is f of x equals a over x plus p plus q. And this is the hyperbolic function. And h of x is a straight line having the equation mx plus c. All right. So what we can see is we are not given the equations of both of these two functions. We actually need to determine them. But we are given everything that we need in order to find those equations. Let's look at the two graphs and analyze these. All right. Well, looking at the straight line, we can see that the straight line is going to intersect the hyperbola here. It's going to have a y-intercept there. And the straight line is going to pass through this point, which we'll give a name a little bit later. And once again, it's going to intersect the hyperbolic function at that point. That's fine. But with regards to the hyperbola, well, it's just going to have a horizontal asymptote at -1, as well as a vertical asymptote at -2. Now, we can already get the values of P as well as Q, because we know that those two, they tell us information about the horizontal asymptote. When we go to the equation here, the one of Q, we just take it exactly as it is. So it's y equals -1, the horizontal asymptote, which means that Q will directly become -1. But with regards to this P, we need to do something a little bit different. The x value here is -2, but when we write it into this equation, we can't say x minus 2. No. We have to say x plus 2. Why do we say x plus 2? Well, that's because we understand that the hyperbolic function was shifted 2 units to the left. And that's how you show a horizontal shift of 2 units to the left. You say x plus something. So when they ask you what's the value of P and what's the value of Q, easy. You'll say P is +2 and Q is -1. So now we know two values. We just need to find the value of A, and then we'll be having the equation of the hyperbolic function, which is f of x, like that. And that's fine. So let's move on and do the thing. Now, which point can we use here in order to be able to find the value of A? Well, we are given one other point that is lying on this graph. It's the point -4 and -5/2. Yes, we can definitely use that point in order to find the value of A. Okay, so here we'll tell them that P is 2 and Q is -1. Then they say, calculate the value of A. Well, firstly, we need to tell them what is f of x. We don't know what's the value of A, that's true. The value of P is 2, and the value of Q is -1. Let's tell them this first. Then we tell them that we are going to substitute a point that is lying on the function itself. And that point is -4. And is it really -4? Of course it is. Well, yes, we tell them that we substitute this point. So what? The y value is f of x, it's -2.5. So according to this point, the y value will be -5 pounds every time when x is -4. And then we say -1 like that. We want the value of a. So the first thing we'll do here is to take -1 to the other side, and it becomes positive. And when you say -2.5 plus 1, well, you actually get -1.5. Then what are you going to have here? You're just going to have a in the numerator and -2 in the denominator. However, if you like, you can actually write this in a rather intelligent way and take your negative into the numerator. It's still perfectly fine as well. Then now you can see that the denominators are the same in this equation. So if the denominators are the same, then the numerators are bound to be the same as well. So the value of a will just be 3. The negatives will cancel out, yes. If the denominators are the same, then the numerators are bound to be the same. But of course, if you don't like that, then you could have decided to multiply both sides by -2. Well, that's still perfectly fine. And you'll still get a nice value of +3. Okay. The next is saying, please write down the range of f of x. That's fine. Now, here we can see something interesting about the function of f. And the interesting thing is the horizontal asymptote. This horizontal asymptote is going to have a disturbance in the graph. The graph is going to be disturbed at -1. So in the actual sense, this is how it looks like. Well, we know that this is going to keep on getting smaller and smaller, getting closer and closer and closer to -1. But of course, it never arrives at -1. Even here, it's going to get closer and closer and closer to -1, but it doesn't arrive at -1. But the most important thing that we know about the range, put in simpler terms, is where the function starts in terms of y values and where it ends. That's your range in simpler terms. So looking at this hyperbola, we say that in terms of y values, it comes from -infinity. But unfortunately, it can't keep on going up because of the horizontal asymptote. So it is forced to stop shortly before -1. Then it continues again. It begins from shortly above -1 and it goes up and up and up all the way to positive infinity. So this is what you can say. It's all the values from -infinity up until -1, or from -1 all the way to infinity. Well, that is your range. Or you can say it's all the values of y. It's an element of real numbers but y cannot be -1. Yes, that's another way of stating the range of your function. Well, just to test, can someone tell us what is the domain of this function? Given that the vertical asymptote is -2, anyone who can tell us the domain of f of x? But it's always nice to have a volunteer, and of course, if no one volunteers, then I'll be forced to ask a person, to choose a person, that is to say. Oh, no
So,
volunteer. Oh, you're volunteering, sir. Yes, sir.
I'll try. Um, is it gonna be x's element of real numbers if x is not equal to -2?
Yes, sir. Yes, that is the right one. Thank you so much, sir. Because the same thing can be said. The function comes from negative infinity in terms of x values. And it's also going to stop at positive infinity. But the problem is it's undefined at -2. So yes, from negative infinity all the way to -2 in union with -2 all the way to infinity. Well, that's the domain. But as you said, it's all the real values of x, just not when x is -2. That is the domain of the function. Okay. No, that's fine. And I really like this question. It says, determine the equation of the line of symmetry, or they could have said the axis of symmetry of the function f that has a negative gradient in the form y equals something. And this is for 3 marks. Well, that's fine. You need to know that the hyperbolic function has two axes of symmetry, or it has two lines of symmetry. Can anyone tell me what is an axis of symmetry or a line of symmetry? What do you think is the meaning of that statement or that phrase? And once again, I really appreciate a volunteer, but of course, if no one volunteers, then I'll have to choose a person. I'll repeat a question. What's the meaning of the word or the phrase axis of symmetry or the line of symmetry? You can explain it in your own words. It shows that you understand it. No one volunteers. Lebu say, what do you say, sir?
So what I know is like it has to do with the gradient. So like if it's a positive gradient, it's gonna move like upwards from left to right, and if it's like a negative gradient, it's gonna move downwards, say like a downward slope.
Sir. No, sir. I don't want to know many things, sir. I just want to know what's the meaning of a line of symmetry or an axis of symmetry. In English, don't tell me about the gradient, sir. I don't know what's the gradient. I just want to know what is an axis of symmetry, sir.
So I'm not sure.
Okay, sir. Do you have any idea, Murendeni, sir?
Um, I think the axis of symmetry is like where it like runs down like the middle. It's like where both sides will be equal. So if like had to like fold it, it would be equal. I think that's what I understand the axis of symmetry.
Yes, sir. That is it, sir. Thank you so much. That is it, sir. It is a line that cuts your graph into two equal parts. That is an axis of symmetry or a line of symmetry. Okay. So if you are studying life science, then you know that human beings have bilateral symmetry, which means that if you were to cut a human being directly in between the eyes, like in the middle of the eyes there, all the way downwards, vertically down, then you're just going to get two equal parts there. Well, that's grade 11 life science. It's rather surprising I still remember that, considering I did matric centuries ago. Yeah, no, it's nice. Okay. This is what I was saying. I was saying the hyperbolic function has two axes of symmetry, which means it has two lines that cuts it into two equal halves. We have an axis of symmetry that has a positive gradient and an axis of symmetry that has a negative gradient. That's what you need to know. But now the most important thing about those values of the gradient is that they are each equal to 1 and negative 1 respectively. So in other words, the line of symmetry with a positive gradient has a gradient of 1, and the one with a negative gradient has a gradient of negative 1. That's very important to know. So in other words, in the case that we are having here, this is our hyperbolic function, and it's a very nice hyperbolic function if you ask me. So it's doing something that is, yeah. But of course, you now understand that tutors don't really sketch nice graphs. They leave this, I don't know this word, to their students. Then their students will really avenge them in the exam by sketching the nicest graphs possible. This is what we are given. I just mentioned the first thing you need to know about these lines of symmetry. It's the fact that they have the gradient of exactly 1 and negative 1. The second thing that you need to know is the lines of symmetry, they always, not when they feel like it, but they always pass through the point of intersection of the asymptotes of your function. That's very important. Well, if you look at the pink one, this part here will be equal to that. This part will be equal to that one as well. So it has succeeded in cutting it into two equal parts. Well, of course, my graph is not drawn according to scale. That's why you don't really see what I'm trying to say, but nevertheless, more or less, that's what I'm trying to say. And the same is true for the pink one. It's dividing this graph into two equal parts, which are those ones. And once again, it's not drawn according to scale, but if you were to draw it according to scale, you'll find that what I'm saying to you is the truth. The gradient is 1, and the gradient is, okay, positive 1 here and negative 1 for the one here. Yeah, that's what we are saying. The point here is terribly important. The lines of symmetry, they always pass through the point of intersection of your asymptotes. In other words, negative P and Q, those are the coordinates of your point of intersection of the asymptotes. So that now that you know their gradients, then you just need to substitute this point in order to get the equation of your line of symmetry. So going back to the question which is given to us here, we need to find the equation of the line of symmetry that has a negative gradient. Well, that's fine. So I'm going to go to my slope point form or point slope form, whichever way you choose to call it. I really like using this formula instead of y equals mx plus c. But of course, you decide which one is easier for you. Now, into this formula, I'm going to substitute the point of intersection of the asymptotes, which is -2 and -1. So that y1 becomes -1. It's the one that has a gradient of -1. And x1 becomes this one. So we have x plus 2 here. And we have -x minus 2 minus 1. So then the equation of my straight line will be as follows. But if they wanted the one with a positive gradient, then it would have still been the same. Well, the same steps. The gradient is 1, and you still have x plus 2 or x minus into -2. So this means for this one, you'll be having y plus 1, which is x plus 2. And therefore, you'll just have x plus 1 as your equation. Two important things, the values of the gradients and also the point of intersection of the asymptotes. Then the last question says, please write down the equations, two of them, the equations of the asymptotes of the function of f. All right? Well, we can easily do that. But now it's not only the function of f, it's not just f of x, it's f of x plus, x plus 4.5, which is just 9/2. Yeah, you don't need to stress how to get it, but in case you do, if you want to convert a mixed fraction to an improper fraction, you say 4 multiplied by 2, and then you say plus 1. So 4 by 2 is 8, 8 plus 1 is 9. But of course, if you are struggling with this, you can just press Shift onto your Casio and then press the fraction. You'll see 3 spaces there. In front, you'll put a 4. On the fraction, you'll put a half. And when you press this, you'll just get 9/2, as we did here. I want us to understand what's the meaning of this. What is f of x plus 9/2? Well, it's still the function of f, but it has now been shifted 4.5 units to the left. That is significant. So I just said it's shifted to the left, which means it's a horizontal shift. The y values are not affected in any way. It's only the x values that will be affected. But of course, it's always nice for you to show the marker that you understand what you're doing. By going to the original function of f, and the original function was x plus 2 here, but now you add it to 4.5, and here you still have your -1. Then you have your 3 in the numerator, and when you say 2 plus 4.5, you actually get 6.5, which is 13/2. and this one is not affected in any way. So that your new vertical asymptote is now going to be at negative 13 halves. And then your horizontal asymptote is not going to be affected. It will still be -1. That was just a horizontal shift.